Hello everybody, this is Miss Smith. Today I'm going to take you through Skills 7.2, which is about charge behavior. Before we get started, please make sure you have your notes out and ready, as well as a writing utensil. Options for taking notes would be to write these on a blank sheet of paper, just everything that you see. You could print the notes that are on the haiku page and just fill in the blanks from there, or you can download the notes and type directly into them. Doesn't really matter because they're your notes. Just make sure you take them because remember, you will have a quiz over this next time. So, getting into skill 7.2, charge behavior. Last time with Miss Fecht, you started talking about the atom and subatomic particles. So one of the things that you saw was this table here. It goes through the three subatomic particles, so protons, neutrons, electrons, as well as some general information about them. The key thing that we need to focus on today is going to be electrons, okay? They're going to be very important to us throughout this lesson. Just a couple reminders about electrons. The charge of an electron is negative. For the purposes of us today, we're going to say its charge is -1. The other thing that you need to remember about electrons is that they're super tiny, okay? Think about protons and neutrons being gigantic, electrons are being super, super small. So like a proton and a neutron could be like the size of a person, whereas an electron would be like a strand of hair, right? Super small, easier to move around. Another reminder from last time is that when you have a neutral atom, the number of protons is equal to the number of electrons, okay? So the positive things have to equal the number of negative things. So if we had carbon, for example, you have 6 protons, so overall charge of +6. You also have 6 electrons, so -6, that charge there. But overall, they cancel out to be 0, okay, making it neutral. The overall charge 0, they're neutral. Today we're going to talk about what happens when the charge doesn't cancel out, when it's not 0, and things start to have charges and how they behave. So, when things become charged, the key thing here is that electrons are what we focus on, okay? So, 2 scenarios. You can have a positive object. So when something is positive, it has lost electrons, okay? You have to lose negative things to be positive, okay? So think about our 2 little atom characters over here. I've lost an electron. Are you positive? Yes, because you've lost a negative thing, okay? If something is negative, that means it has to gain electrons, okay? This is where there's some confusion that could come in. You gain something, but you become negative. How does that work exactly, okay? Think about if you have a little person here. Okay, our lovely person. Apparently their arm isn't attached, but they are very happy. They're walking and they see some electrons here. Before anything happens, this person is neutral, okay? Charge of 0. But let's say they're walking around, they're greedy, they want to pick up one of these electrons. So now that they've picked up an electron, now you have the same person. Yay. But now they have a -1 charge. They're not neutral anymore. They have a charge of -1 because they picked up one of these electrons, okay? What would happen if they picked up 2 electrons? Well, now it's not -1, now it's -2 because you picked up 2 negative things. If you pick up electrons or gain electrons, you will become negative because electrons inherently are negative, okay? That's what you need to remember kind of throughout today. Another key thing is that objects cannot gain or lose protons, okay, for 2 main reasons. 1, protons are bound to the nucleus, okay? They are confined in a tight area with a tremendous amount of potential energy in there, right? Nuclear energy. So you have this nucleus here. Think about these electrons as forming kind of like a cage around this nucleus, all right? They are going to protect the nucleus. It takes a tremendous amount of energy to go in and pluck one of those one of those protons out from the nucleus. Another reason why you can't gain or lose protons is because elements depend on their number of protons, okay? So let's say you have some atom and it has 6 protons. We did this one earlier, right? This is carbon. You have 6 protons, you are automatically carbon. Well, what happens if you were to gain a proton? Well, now with 7 protons, you are not carbon anymore. Instead, you are nitrogen, okay? The number of protons will determine the element, okay? They are important, so we don't want to touch those, okay? But we can gain or lose electrons without changing the element itself. So electrons, that's what's important. They are what move around. So let's talk about some possible questions that you could see. When you brush your hair, you scrape electrons from your hair. So the charge of your hair is A, positive, B, negative, C, both A and B, or D, neither A nor B. So let's talk about what happens here. When you are scraping electrons from your hair, well, what happened to your hair? You're scraping electrons from it, so you have lost electrons. Well, what happens when you lose electrons? Well, you become positive, right? So positive A is our correct answer there. Your hair is now positive because it's lost electrons to the brush, okay? Well, if we have the same scenario, what's the charge of the brush, okay? The brush has scraped electrons from the hair. So the brush has gained electrons. What happens when you gain electrons? You gain negative things. You are now negative. So B would be your correct answer there. So let's talk about electric force. Luckily, you already know some of this offhand, right? Opposites attract, we know that. Well, let's talk about why. Here, you have a negative thing and a positive thing. They are going to inherently be attracted to each other, okay? They each have something that the other one does not, making them attracted, okay? But if you have two things that are the same charge, so here in scenario A, they happen to both be positive, but they could have also both been negative, same thing, they would have repelled away from each other, okay? Like charges repel, opposite charges attract, okay? Think about a magnet, okay? So if you have two magnets and you try to stick two sides together, but they don't quite want to go together, you kind of have to force them to touch, and then as soon as you stop pushing so hard, they kind of push away again. Well, that means you have like charges, either the two positive ends or the two negative ends, or the north poles and the south poles. But if you flip one of them around, then they stick together, then they're happy. Then it becomes this scenario here, okay? Because opposites will attract towards each other. So we have a couple scenarios here. We're going to talk about the electric force, okay? So the force occurs between two or more charged objects, okay? So we have three scenarios over here on the right. So I'm going to call this scenario 1, 2, and 3. The electric force depends on two things. One is the strength of the force, okay? Strength of the force. The other one is the distance, which we'll talk about in a second. So the stronger either charge is, the greater the force, okay? So let's look at scenarios 1 and 2 here. In all three scenarios, this object is the same, okay? That's constant all the way across. But the object to the left changes, okay? Either by size or position. Object 1, it's a larger object. You see more charges around it here. Object 2, it's smaller here. So think about which of these two scenarios, 1 or 2, would have a greater force. Well, the one with the greater charge will have the greater force. So scenario 1 will have the greatest force. Okay, greatest. Compared to scenario 2 anyway. The next thing that it could depend on is the distance between them, okay? So the more distance between them, the less force there is. So in scenario 3 down here, you have all of this empty space for that force to travel through, okay? Because there's more space here, there's less force. So in these three scenarios, 3 will have the smallest force. Okay, so 1 will have the greatest, 2 is in between, and then 3 will have the smallest because, again, of all that distance, and it's a smaller object. All right, some of you may find this shocking, but electrons can travel through different materials. Okay, we're going to get into those two main types of materials in just a moment. But let's say it's the wintertime, and you're scooting your cold feet across the carpet. If you have wood floor, just use your imagination. So as you are shuffling your feet across the carpet, think about the brush, right? Your feet, as it drags across the carpet, is going to be taking electrons from the carpet. As the electrons go onto your foot, they can travel up our bodies, okay? So you can see electrons traveling through this hand here. The electrons are traveling through, okay? Your hand is now a charged object, okay? This doorknob, we're not going to get too heavy into this, but basically the negatives are over here, positives are over here. So the positives here are attracted to the negatives here. So because they're attracted, these electrons can jump over to the doorknob, okay? Because as they get closer, right, that space is decreasing, so the force is increasing. So the spark caused by the moving electrons the spark is caused by those moving electrons, right? It's moving or jumping through that gap there. All right, so electrons can travel through our bodies because our bodies are what we call conductors, okay? So basically it's a material in which electrons are able to move easily. So the electrons can travel through our bodies. They can also travel through metals. So a great example of conductors would be metals, okay? They're great conductors of both heat and electricity, okay? So think about, for example, if you go to take a bite of like this really hot soup, go take a bite with a metal spoon, the spoon's going to be super hot, right? It's going to burn your lips. It's because they are metals. They are great conductors, okay? Conductors are also used in electrical wires. We're going to get into those in just a second. So some examples of conductors, you have a bunch of examples here. There are some of these in bold that you notice. These are the ones that are just already typed into your notes, so you don't need to write those down. If you are writing this on a blank sheet of paper, please write those examples, okay? Really, the key ones that you need to know is metals in the body. So the opposite scenario here is called an insulator. So an insulator is, again, just the exact opposite. So it's a material in which electrons are not able to move easily, okay? Think about plastics, right? So if you look down here at this picture, we talked about electrical wires a second ago. So the inside of those wires, that is your metal. So in the last 2 slides ago, it said either copper or silver. It's going to be inside the wire, but the wires are coated in this plastic, okay? It's coated in an insulator. Well, that's to protect us. That way we don't shock ourselves all the time with wires everywhere, okay? So it coats around those metal wires and it protects us, right? So plastics, and then some other examples that you see here. So glass, rubber, asphalt, things like that, okay? Again, bolded words are just the ones that are already pre-typed in your notes, so don't worry too much about these, but you do really need to focus on plastic. That's going to be the big one here. 2 more scenarios that you can see. We're not going to press too hard on these. We just want to kind of mention them. The first one is called a semiconductor. So that's a material that can be adjusted to either be a good conductor or a good insulator. So it's adjusted basically by its surroundings, and you can move around a lot of variables there. And then superconductors are the other one, okay? So these are certain metals that become perfect conductors at very, very low temperatures. So absolute zero, that's going to be 0 Kelvin. Absolute zero, super, super cold. So an example of that is mercury. So just to wrap up, we've talked about how electrons will determine the charge of an object, electric force, conductors, and insulators. So these are kind of the main ideas that we've talked about so far. What you should focus on now is completing your 7.2 IP, which is about charge behavior, and then we're going to have a quiz over that next time. If you have any questions, please pop into your teacher's office hours or email them. That way we can get those issues ironed out. Thanks.